Today we're going to continue learning about VSEPR, valence shell electron pair repulsion theory, and by looking at 4 additional shapes that can form in molecules. The first one we're going to talk about is trigonal bipyramidal, which is the shape that would form when you have 5 atoms bonded to a central atom, as you would in the case of PCl5. And what that would essentially look like is you would have, in the flat plane, you would have 3 atoms spread out about 120 degrees apart, and then you would have an atom sticking off the top and the bottom. So you would have bond angles of 120 as well as 90 degrees within that molecule. It would have a generic formula of AX5, and you can see there's no unshared pairs causing any type of repulsion. The next type I'm going to talk about is the octahedral shape. And the octahedral shape is what results when you have 6 atoms bonded to a central atom, as you would in SF6. And basically what you have is a Cartesian coordinate system where you have an XYZ plane, or XYZ axis, with an atom at each end of each axis. So you end up with nothing but 90-degree bond angles, and this is what you would get with SF6, generic formula. AX6, you can see no unshared pairs causing any additional repulsion. Now, slight modifications to these 2 shapes. We have square planar, which is a slight modification of the octahedral shape, and we have the seesaw, which is a slight modification of the trigonal bipyramidal shape. When looking at the square planar shape, which is something we would get with xenon tetrafluoride, where you have 2 unshared pairs as well as 4 atoms bonded, what would happen if you would end up with a flat molecule as a result of the 2 unshared pairs, one on top, one on bottom, forcing the other atoms into a flat plane instead of forming a tetrahedral shape. The bond angles here would all be 90 degrees, and the generic formula for this would be AX4E2 with 4 atoms bonded to the central atom and 2 unshared pairs. And lastly, we have the seesaw shape, which you essentially get from a trigonal bipyramidal structure with one of the atoms being replaced by an unshared pair of electrons. So the electron geometry would still be a trigonal bipyramidal, however the molecular shape would give you that of a seesaw. And you would have bond angles of approximately 120 degrees as well.